a binary search tree. The code for this is available in the comment area. It has three cases. One is if the node is the leaf node, then it is very simple, you simply delete this node. And the other case is if the node has only one child node, either left or right. It's also simple, we simply remove that node and connect the parent node with that child node. That child node may be on the left side or it may be on the right side. So if it is that on the right side, and then simply we will do the same thing. We will remove that node and we will connect the parent node with this child node. So this is very simple cases. So next case is a little complex and important. It is if a node has both left and right child. For instance, we have to delete a node having both left and right child. So this case is very important, you need to understand it. So let's say we have to delete a node having value 6. The node having value 6 has both left and right nodes 5 and 8, and in this case what we will do, there are many algorithms you can find on the internet, but we will follow a very simple algorithm. And according to this algorithm, we'll go to the right node, and from the right node we'll go to the leftmost child of that right node, and in this case the leftmost child of the right node is 7, and we will simply remove the node that we want to delete, and the left child of the removed delete will be connected as the left child of the right of the leftmost child of the right node. So 5 has been connected with the 7. So this is how we delete a node having both left and right childs. So you can further understand this concept in the coding, and the coding is available in the comment area of this video. Let's further understand this concept in another diagram. Say you want to delete this node, and you will go to the right node, child of this node, and the let's do it again just for understanding. Say you want to delete the 6th node, you will go to the right child, that is 8, and you will find the leftmost child of this right child 8, leftmost child is 7, and you will connect the node having value 5 as the left child of the 7. So this is the whole procedure, and now at the end 10 will be connected with 8. So let us similarly you can execute this case for node 14. Node 14 is deleted, 11 connected with 17, and 10 connected directly with 18. So now let's see the code for it. Remove function is called from main function, and it further calls the function delete node. Here we pass the value that we want to delete and the root address of the root node. And here in this portion we search the node that we want to delete. So we simply compare the value with the root node. If it is left, we go to the left side recursively. For instance, say we want to delete the node 6 and we compare the value 6 with node value 10, and here you must understand that we have passed the root as an address. You say it we have passed the node as passed by reference. So passed by reference is used if you want to actually pass the variable, not the copy of that variable. Here we compared 6 with 10. 6 is less than 10, so we again recursively call this function, and this time 6 is passed as a root. And so this piece of code is just to find the actual node that we want to delete. So when 6 is passed as a parameter and also as a node, then this make deletion function is called, because it is and in the make deletion function we actually delete the 6 node. And in this function, if node pointer is null, it means we couldn't find that node that we want to delete. So otherwise we look for the cases where at least one child is null, either right is null or left is null. And so in these cases it is quite simple. You simply remove the middle node and connect the parent with the grandchild. Like in this case, if right is null, like in the case of node having value 18, what we will do, we will simply bypass the node 18 and we will connect the 14 with 17. And this node pointer is equal to node pointer left. It is a little important statement to be understood, because we want to delete 18, so node pointer is actually pointing towards 18, but the right arrow, the right pointer of the node 14 is also same, because we have passed the node pointer as an address, as a, you can say by reference. So the right of node 14 is same as node 18. So when we say node pointer is equal to node pointer left, it means we are updating the right arrow of 14. So now right arrow of 14 becomes the node 17. So this is a concept that you need to understand if you that you must understand if you have already covered the topics of pointers. So not very difficult concept. You simply need to understand how to pass a pointer by reference and how to update a pointer if it is passed by reference. And this is the most crucial case where a node has both a left and right child. Like in this case, we want to delete the node 6 and it has both left and right child. So what we will do, we simply take a variable pointer, temp node pointer, and now it's pointed towards the node pointer right. Node pointer is actually 6 and node pointer right is 8. So we go towards the node having value 8, and then here we run a loop. The loop will find the leftmost child of this node, and in this case the leftmost child is 7. So we stop at when we get the node 7. So here what we will do, we will connect the node having value 5 with the as the left child of this node 7. So temp node pointer the arrow left is equal to node pointer left. It means now 7 is pointing towards 5. And now we want to delete the node 6. So we kept it in the temp node pointer, and then we want to update this arrow, the left arrow of root node, you can say the left arrow of the node having value 10. And to update that pointer, we have written the statement node pointer is equal to node pointer right, because node pointer is pointed towards 6 as well as towards the left arrow of 10. So when we update the node pointer, we are actually updating the left arrow of the node having value 10. So again here the concept is same of passing by reference. When you pass a pointer variable by reference, then you can do these type of things. So the statement node pointer is equal to node pointer right is actually updating the left pointer of node having value 10 towards the node having value 8. So this is it, quite easy, and the code is has been pasted in the comment area and you can try it yourself. Thanks and stay tuned.